Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Allow me to introduce myself. I'm Intan Wandira from Lampung University. Today I'm going to talk about my paper. The title of my paper is The Influence of Distance Between Needle Tip and Collector on Formation of Titanium Dioxide Nanofiber with Electrospinning Methods. Here I'm going to present my paper in 4 parts. The first part is introduction. The second part is material and methods. The third part is result and discussion. And the last part is conclusion. Now we start to introduction. Nanofiber is one of nanotechnology application in the form of small thread with a diameter of 500 nanometers. Nanofibers have the characteristic of a high surface area and interconnected porous structure and conductive. With this characteristic, researchers are interested in developing nanofiber as filter for submicron-sized particles. With a smaller order, nanofiber enable optimizing of dust filtration in the air. Titanium dioxide is better because it is cheaper and non-toxic. As a high-performance semiconductor, titanium dioxide and nanofibers have more potential application as filter materials, photoresistant films, dust sensor, humidity sensor, solar cells, and photocatalysts. Electrospinning is a widely used method for obtaining nanofibers because it is efficient and allows obtaining nanofiber in the minimum size range of 40 until 200 nanometers. Electrospinning is considered effective in the production of nanofibers because it is cheap, convenient, and allows the use of various materials. Recently, HESM has synthesized CO2 PVV nanofibers at the tip-to collector distance of 6, 9, 12, 15, and 18 cm with TTIP as precursor, acetic acid as solution stabilizer, PPP as polymer, and ethanol as sulfate. Based on SEM data, the best nanofiber are at a distance of 15 cm with a diameter of 65 nanometers, and based on XRD data, the best form is the annotated phase. The above explanation underlies this research, namely the manufacture of CO2 PPP nanofibers whose solution was synthesized by the solder method and spun by electrospinning technique. The electrospinning process is carried out by varying the distance from the tip to electrospinning collector to see its effect on the size and uniformity of the diameter of the fiber formed. The viscosity and surface tension of the solution are monitored to show that the resulting solution can be electrically spun. Sample characterization was performed using SEM, EDS, and XRD instrument. The second part is material and methods. Materials. In this research, we use titanium isopropoxide, which obtained from sigma aldrite, acetic acid glacial, methanol and ethanol were obtained from MERS. Polyvinyl pyrrolidone were obtained from RRC. Synthesis of CO2 PVV nanofibers. The synthesis process is defined into dissolving polymer and mixing CO2 PVV solution. The polymer was prepared by dissolving 1.3 gram of PVP in 8 milliliter of ethanol for 30 minutes while stirring at 350 RPM. The process we can see in figure 1. Next, a solution of CO2 was made by mixing 2.5 milliliter of TTIP with 3 ml of ethanol, then adding 2.5 milliliter of acetic acid gradually while stirring for 5 minutes at 350 RPM. The process we can see in figure 2. Then the two solutions were mixed by adding the titanium dioxide solution gradually into the polymer solution and stir for 1 hour at 350 RPM. Measurement of the viscosity of the solution is done by looking at the flow rate of the solution on the osmotic viscometer and calculated by equation 1. Furthermore, the surface tension was measured with a tensiometer and calculated by equation 2. After measuring the viscosity and surface tension, next to do electrospinning process, we can see in figure 4. The figure 4 shows schematic of the electrospinning process. In this process, we vary distance between tip here and collector, namely 7, 9, 11, and 13 centimeters. Characterization. CO2 PVV nanofibers produced by electrospinning were characterized by scanning electron microscopy, energy dispersive X-ray, and X-ray diffraction. Particle size was calculated using the Serre equation. The third part is results and discussion, viscosity and surface tension. This is table 1, result of viscosity measurement. The resulting viscosity value of 2.889 Pascal second indicate that the CO2 PVP solution can be processed by electrospinning technique. The surface tension value of CO2 PVP solution obtained based on calculation using equation 2 is 28.9 plus or minus 3.7 dyne per centimeter. This value was expressed as the value of surface tension of the solution that can be used in the electrospinning process. This is a figure result of same instrument for all samples. From the 4 samples, the fiber size of ES7 obtained appears to be larger than that of the longer distance fibers. The fiber size is relatively smaller than other samples as seen in the ES11. However, the ES9 showed presence of beads. See? The presence of beads produced on the fiber is thought to be due to several contributing factors, including viscosity, surface tension, and electrical force experienced by the polymer solution. From the result of the diameter measurement, the observed diameter of sample ES7, ES9, ES11, and ES13 were in the range of 56 nanometers to 961 nanometers. The increase in the distance between needle tip and collector obtained optimum distance at 11 centimeters. And this is figure of the graph of influence of distance between needle tip and collector on the average diameters of CO2 PVP nanofibers. The relationship between needle tip and collector with the average diameter of the nanofiber can be seen in figure 7. This is by looking at the estimate standard deviation, it can be seen that the graph of the average diameter of CO2 PVP nanofibers has an optimization trend and increase with increased distance. And here, elemental composition of CO2 PVP nanofiber sample ES11. The EDS spectrum showed the presence of 4 constituent elements, namely element C with a mass of 48.80%, O with a mass of 25.29%, Ti with a mass of 17.12%, and Si with a mass of 8.79%. EDS saw less impurities such as silica in prepared titanium dioxide. XRD analyze. This is a XRD diffractogram of sample ES11. The result of qualitative analysis of the diffraction peak suitable from the annotated base in the ICDD file database 010758X97. In this study, the highest annotated peak was at position 25.34 degree, as found in several studies. As shown in figure 9, rutile and bulkhead base are not visible. This is because calcination temperature used in only 450 degrees Celsius. And this is as XRD plot for sample ES11. The refinement result is quite adequate, indicated by the decreasing of the R factors during the calcination process. This is a table to the lattice structure parameter value, criteria of fit value, goodness of fit value, and the mass fraction of the phase formed for sample ES11. From the table, it can be observed that the phase present in the annotated space. In addition, it can be observed that the RVP and RP value obtained are less than 20% and GOF value is less than 4. Thus, it can be said that the refining quality obtained in this study is quite good and in accordance with the indicator of success. And this is tab 3, particle size calculation results. The particle size obtained is 12.3 nanometers. The results obtained are slightly different from Hazem study, which is 65 nanometers. The calculation results show that the size of ES11 sample of CO2 PVV nanofiber is nanoparticle. Thus, it can be concluded that the material prepared in this study is included in the nanomaterials category. And the last part is conclusion. Based on the synthesis result, CO2 PVV solution with a viscosity of 2.8 Pascal second and a surface tension 28.9 plus or minus 3.79 per centimeter can be spun into CO2 PVV nanofibers by electrospinning methods. The distance between tip and collector has been sought to effect the formation of CO2 PVV nanofibers seen through the surface morphology and fiber diameter size. The surface morphology indicates that the CO2 PVV nanofibers are relatively uniform and continuous. Considering the estimate standard deviation, the graph of the average fiber diameter showed the optimization trend. The result of SEM analysis showed that diameter size was in the range of 56 nanometers to 0.961 micrometers. To ensure that nanofibers contain titanium dioxide, it was further confirmed by XRD result, which showed that the crystal structure formed on nanofiber was the annotated phase with particle size ranging from 12.3 nanofibers. Okay, so I think that's all of my present. I hope this make you enjoy and give you information. Thanks for all and goodbye.